is. So I threw the link to our working group doc in the chat. And today's meeting, we're going to go over the application sets and what they mean to us in a little more detail. I did write up a document about how it kind of fits in with our world. And that is not the document.
Is your document in Google Docs?
Yeah.
We can.
I just don't remember what I named it now. Oh, I put it under the architecture group. Let me find it. But one of the things I went through the basically the concepts of what we have going on in the I'll never find it.
I'll look for it, Steve.
Okay,
I
somehow let me look at recent.
found it.
There it is.
Putting it in the chat right now.
So one of the things that when I went through and was looking at what they were talking about between Argo and Spinnaker, one of the things I kind of knew this going into it was terminology throws a whole new loop in this ball game. And I think Crum, you ran into that as well when you're listening to the recording. You know, the term application is just reused over and over in different contexts. So what I try to do is break out what an Argo CD application is and what an application set, and then did the same for Spinnaker and then for us. So just a high level in the where I kind of see the GitOps and the Argo CD, which is a GitOps based implementation coming from. The angle that they're looking at is initially around the deployment of a single image into a Kubernetes cluster. So it's deploying a monolith into Kubernetes. And because they're deploying a monolith, they were calling that an application. The same thing happened in the Netflix world. Netflix, they were deploying VMs basically, or EC2 instances out to AWS, and those were the applications. So those pieces of their monolith running as what they would call an application, because it's actually on a EC2 instance. None of it was, neither one of these tools were initially focused on microservices. So now as things get broken apart into smaller pieces, the problem is that their terminology isn't keeping up with the times, and also their implementations aren't able to keep up with what needs to be done. In the Argo CD world.
Steve, can I ask a question?
Yep.
Does Argo CD have a GitOps operator of its own?
Yes.
Oh, okay.
And that's how come you could see Argo CD married up with like CodeFresh. So,
but CodeFresh doesn't have, CodeFresh is just reporting on things, right?
CodeFresh is like us. They have their own deployment engine, but they are more of a pipeline that is trying to conform to the GitOps model. So they let Argo do the underlying sync of the cluster. So one of the things that I found interesting is um, on the Argo CD side, what they look at is what they're calling manifests. You could have a deployment manifest, which is actually going to be the YAML for defining the basically the container image and the pods um, to Kubernetes. And then you have a service manifest, which is all the networking pieces to connect the inbound with uh, the pod. So those are typically packaged together. They may live in separate files, um, but that is what that's the only like relationships that they kind of have is
S-
pulled together at that level.
So I don't understand the difference. Is a What's the difference between a service manifest and an environment manifest in a tradition, what they call an environment repository?
So a manifest in Kubernetes is going to be a chunk of YAML code that defines the inputs to a particular Kubernetes resource. So a deployment manifest is used to define your pod. A service manifest is used to define your ingress and egress. You'll have config map manifests that define um, configuration parameters. And there's a whole nother, there's other
And
sets.
all of those manifests live in the environment repository?
Yes, they could be smashed together in one big YAML file, or they can be broken out into individual YAML files, but they all live within the environment repository. And what the environment repository is the repository that's being used to do the deployments from and to sync to. So what ends up happening is you have your source code repository, which is your Golang or Python code that is separated from the deployment part of it, which is called the environment repository. So in the GitOps world, you have two sets of repositories, if not more. Um,
And how is Argo CD making that different? They're not, right?
Making what different?
Having two repositories. Do they have an additional repository that they use?
Yes, they in the Argo CD world, um, in order to keep a check-in of a source code from triggering a deployment, even though the build hasn't completed, you have to break it into two different repositories in order to get the triggering to work in the right order.
Is that a problem for everybody if GitOps, like with a
Yeah,
stand?
yeah, that's the problem with GitOps in general.
Oh, we need to talk about that for my blog.
I tried to explain it to you the other day, and it
Yeah, that sounds like there's
just
merge
wasn't.
you're talking about some kind of a merge conflict then.
No, what it is a triggering chain. So um, when you have a source code change coming in, that's going to trigger an action in the repository. When you check in source code, the action that you want it to execute is creating the image, which means you have to go basically compile your code, create your image, and publish your image to a repository. That's typically what you want to happen on a source code check-in. And if you have the source code and the deployment manifest all in the same repository,
No, I get that. I thought that you're saying that that was a problem if you had separate repositories, and that's why Argo CD created a third repository.
no, they use a minimum of two basically.
So they have still a source code repository and an environment repository, and all the manifest files are stored in that environment repository.
Hmm.
Yeah, like everybody else. So what does Argo CD bring to the table?
Just another implementation. This is a competitor to Weaveworks, and there's another one out there. There's another open source one called Razor by IBM.
Mm-hmm.
That's a GitOps model as well. Um, Seems to be a little more mature than Argo because they dealt with the application set um, concept was already fixed by Razor. So what happens in this GitOps world is you need to be able to separate the data from the definition, even though you want it to be immutable and hermetic. In order to roll out to hundreds of clusters that have unique information, you have to basically separate out that information. And because you're in the GitOps world, every time you make a change to the environment, you're going to actually trigger out another, you end up in this circular loop as part of that process. So what the application sets in Argo CD are trying to do is dealing with configuration. Um, and it's really trying to separate data from definition and do like a templating process. But it's very hard when anytime you touch the environment repository, things all of a sudden start taking off. Um, so the concept of application sets in Argo is really focused on what they call generators, templates, and the sync policy. Just to give you an idea, I took some of the use cases just to really help simplify some of the concept that they're trying to get to in application sets. Um, so in this case, they want to install a set of identical manifests across all clusters. For example, install the same Helm chart across all clusters. So that's one of their use cases that they have, that the application sets through the generator and the templates can be used to push in data into the Helm chart. Some of the other ones, the same Helm chart, but different values for every cluster. Uh, let's see, I want to deploy multiple versions to the multiple namespaces with different configurations. Those are the types of things that they're really trying to address, is how to get this metadata into a template with it still all being hermetic and all in Git, and saving all the history and everything like that is what they're trying to achieve. Um, so that's where the application set comes from, but it really has nothing to do with relationships between applications.
It's just
Nothing,
trying. It's just trying
nothing
to.
at all.
Yeah. It's just trying to manage a single uh, manifest that may have different values for different clusters.
Yep. It, it literally is trying to be able to like generate these things on the fly. And that's why I was saying, like Razor, they figured out this whole process as well of separating data from definition, being able to deploy to hundreds of clusters
And do we?
already.
And don't we do that
We
with
handle it
K?
very easily
Yeah.
because we tie the data to a component application environment endpoint. We don't have the data tied to the actual implementation, so we don't push data into a Helm a Helm chart, for example. We'll take our data from Ortelius at the application component, whatever level it's coming from, and create what's called an overrides file that will allow us to override any of the values that it's already in the existing Helm chart. So because of that, we're
And
able
those
to reuse
and
that.
that data comes from the key value pairs that we are managing.
Yeah, yeah, or
Or
just
yeah.
base definitions of the component. Like in the base definition of a component, we have the image SHA, the image tag, the registry that it was pushed to. So that information will get pushed into the Helm chart as an overrides. So we never have to go in and update a Helm chart. We actually just pass in the data into it as part of that process. And Helm's a great templating engine. It's based on Golang, and Golang has a very strong templating process engine built into it.
So is there really anything we can do for Argo CD? Is there something that we can do to pass them the override file with the Helm chart?
I'd have to look at that because one of the things Argo and Chrome found this as well. Argo is not a CI/CD tool. It literally is
Right.
a sync tool. It's really more. I would call it more of like a state management tool than anything else.
And could we then take our override file in our Helm chart, generate the Helm chart, and push it to them?
Yes,
But that's what they're doing already. And where are they storing all of the data to do that?
I don't know. I have to figure out at the where the the application set is storing this additional data as part of that. I don't know if it's in their UI or how it's getting managed and how they're basically after you apply let's say you have to apply a new namespace name as part of your, like in this case, install the same Helm chart with different values for every cluster. I don't know what ends up happening on the Git repo side, if they are actually checking in something just for that cluster to let it sync and then they go on to the next cluster and wait for that. So they have this big serial process that has to happen because it's all up against the same repo. I didn't get into the exact implementation that they did.
Okay. All right, well, let's hear about Spinnaker then.
One last thing on Argo, they did say they need to aggregate, they call it aggregation of applications and an application set is a future requirement as part of that. So they are looking at this concept of an aggregation at some point. Any questions on Argo before I go on to Spinnaker? Spinnaker is a lot easier to wrap your head around. So that's why
So
it's much
that
shorter.
last statement, Steve, when they talk about the aggregation of applications, is that like full-on solutions that are being pushed out like a release train?
No, let me go to there.
Are you remembering to also ask something just now?
It was they had like one little future. Come on, catch up. So this is their proposal. So I put the link in there. They literally have like one line
You
about
just passed
future.
it. Yeah, you just passed it. Right there.
No, that's
Future generators.
yeah. Oh, that's generators. Get generators, cluster generators.
So maybe what we have to do for Argo is maybe we can pass them the aggregate.
Yes, and like they have these templating engines, and we may be able to pass them the data for these templating engines.
Okay, so I think what we should do is get put together, if you can have some ideas of what benefits we can bring to Argo, and then I'll circle back around with the Argo team and ask for if we can do a follow-up call to let them know what we're thinking.
Yeah. Let me find where.
You say Argo is more like a state management tool.
Yeah.
It's more like a chef or a puppet, right?
Can I?
Yeah. It's exactly the concept of Puppet. I don't know if anybody's familiar with Puppet.
So could I also use an analogy like a Terraform state file? Would be similar to something like that.
I believe so. Yeah, it's going to be keep this thing and that's the whole GitOps concept is Git is going to be the desired state and always bring, even though these tools can do overrides, but the concept behind the GitOps is Git is going to be my desired state, make my cluster look like my desired state.
So I'm writing a blog right now for our blogathon on the pros and cons of GitOps, and it's in the blog directory in our Google Docs. So if you guys want to take a look at it and give me some feedback, that would be huge. And I think it defines GitOps fairly well. I'm also doing a presentation for Skill Up Days, which is on the 25th. And I did did a presentation on it. So I'm learning as well. Learning and talking about it is really hard, but it covers some of these topics that Steve just covered.
So this is all they have for future requirement is a higher level aggregate view. And then there's a comment from Danny Thompson saying, what is the future view going to look like? What is the user's experience? And that's as far as they got.
Well, I think that if we can come up with a few talking points, I can get another call with that team, and we'll see what they have to say, if if they're interested at all in doing any integration with our catalog.
So one of the things on Argo, their what they call a deployable unit is the smallest deployable unit is going to be a manifest of some sort. So it could be a service manifest, it could be a pod manifest, a deployment manifest, a config map manifest. So that's what they're looking at, and that's because, and the reason for that is that's the smallest unit in Kubernetes are these different objects in Kubernetes. So just keep that in mind. So if you check in, 10 different deployment files into your environment repository, and 3 of them have changed, they'll go ahead and send those 3 out as part of the process. Spinnaker is much easier to wrap your head around. And like Karam said, Spinnaker is a CI/CD tool. So it has a full CI/CD pipeline. If I can type here. And in the Spinnaker world, like I was saying when we first started talking, is in their world, an application is defined as a deployable unit. And what that deployable unit can be basically any manifest. And the way they actually, let's say you want to do WordPress. So WordPress needs not only the WordPress container image, but also it may need like a MySQL container image as well. So there's 2 container images that need to be deployed for WordPress. What you would do is you put both of those into either a single Helm chart or a single deployment YAML file. And because you have, and that's the way they do their grouping, is by the developers actually concatenating together these YAML files into basically one big one that will be passed to Spinnaker to do the work of deploying it over to the cluster.
And they're not using Git. They don't have a Git operator. They're not referencing Git as a single source of truth. They're not. You can build that if you want to.
Right.
But it's not part of that solution.
No. And I did not get into exactly how Spinnaker is storing or referencing those manifests. I would imagine that it's either going to be a pointer to a manifest that's in a repository, or you have to like upload it into the Spinnaker tool. Does anybody know? Has anybody actually worked with Spinnaker before?
So it's got a couple of different options. It can either be configured inline, actually in the pipeline, or it can use, I think, external pipeline repository storage. I'll see if I can dig out the documentation on it. But when I was looking at it previously, it's got 2 ways of doing it.
Yeah, that's kind of the feeling I got around how they're doing it as well. And you end up having a different, I don't remember if they call it a job or a workflow, but let's say you want to go to QA. You're going to have a QA job that defines for this deployment. This is the manifest that I want you to use for QA. And then you define another job for production that is totally separate from the QA one that you have to then redefine to go to the production part of the world. And I believe they can chain together one job to the next job as part of that. But at the end of the day, they don't have any concept of aggregation either. Because they're doing all the grouping of resources at the manifest level, it's basically hidden. I mean, you can technically get to it because as in YAML, you could go parse the YAML and figure out the relationships, but it's not obvious to the end user, put it that way. Like I said, the Spinnaker is more traditional. You can think of a Jenkins, Jenkins X type of thing along those lines, the pipeline. So it's not going to be outside of that, those concepts that we already know. So I've just brought in what we have on the Ortelius side, so to bring everybody up to speed. For us, we actually look at a deployable unit as actually a source code change. So when somebody actually checks in a coding change, you check in some Python code, you're going to create a new artifact, and that artifact is what we're going to track. That artifact being a container image, or a ear file, war file, doesn't really matter to us. But basically, in the world of Kubernetes, we equate a component to a container image. Kubernetes services and config maps, we can define those as components as well, but I think it's a little bit too granular. And those are typically bundled together with a deployment manifest and a Helm chart. So when somebody defines their deployment via Helm, they kind of give everything that's needed to make this container image run. So whether it be the config map, the service definition, or the pod definition itself. So we work at basically the Helm chart, and like I was saying, we pass in all the data into that at deployment time. So we do have that separation at that level. So every source code change will create a new container image, typically through the build process, which in turn creates a new version of the component in Ortelius. Now, in our world, applications are aggregated together. When we look at an application, it's a set of component versions. I didn't get into too many details about domain-driven design and that, but that does overlay on top of that. We also do versioning of the application versions. So if you create a new component version, then you have a previous version of application, we'll go ahead and create a new application version as well. This gives us that incremental history chain that we can traverse through the relationships. What this allows us to do is look at the different points of view.
Hey, good morning and good evening. Any blockers for anybody? Anybody wants to discuss anything?
What was that? You're breaking up a little bit.
I've got a question for the group, but I'll wait. Looks like Brandon had an update to share. I was just going to say no wonders yet.
So we can have a different point of view.
Just want to build on your radar. Envision Inspect is a tool to use to understand the exact UI positioning of rhythms.
Let me put that on mute. All right. So we could take a different, we have different points of view. What component versions are application version consuming? From the component side, who am I affecting? The blast radius, as Tracy calls it. One of the things that we are currently missing is a component to component relationship. We have not built that in to the whole process. And that's where I'm thinking of what we would call them as component sets, where we can actually group together a set of tightly coupled services, call them a component set, and then an application can actually consume either a component version or a component set version as part of that process. Now, one of the things that we have to look at is if we want to allow a component set to include a component set itself, and kind of do that nesting. That I'm still out on, the jury's still out on that one. It does add a level of complexity, and I don't know if people need that right away. So just to clarify some terminology, since both Argo and Spinnaker are missing the relationship management in those tools, what we might want to do, and this I kind of threw it out there on the talk when we're meeting with them, the concept of a product. So instead of using application in Ortelius, that we change it to a product. So we would deploy a product, or we'd be managing a product instead of an application, just to keep us less confusion between the different tools. So my recommendation would be we rename application to product, and we implement component sets as tightly coupled relationships between components and consuming. I did lay out some relationships here, so you can kind of see, kind of like from a database perspective, how things are associated to each other. I'm not going to go through all the detail as part of that. And then I did try to kind of draw up the concept that we're looking at. So in this case, we have the blue circle is product A. We have a set of components and a component set. We do have a shared component between product B, and these are actually both product A and product B have been deployed to the QA environment and the prod environment. That's why it's overlapping here in the middle. These relationships are very hard to draw because we not only do you have relationships at the product level, but when we look at the deployment of where it went, looking at it from that aspect as well when we're bringing the environment world. So that's
Steve, I have a question to clarify on the GitOps side and the Argo. In Argo's world, the product A circle, everything in the product A circle would be stored in an environment repository, including the shared component. Is that correct?
Correct.
So in the GitOps world, everything that product A requires is in the manifest stored in that product A's environment repository.
Correct.
Okay.
And then you redefine that.
And product B would be referenced in two places.
Yeah, this shared component would be referenced in two places. So let's say you need to add a new key value pair to this shared component. You're going to have to find every single repository that has that definition for that shared component and go ahead and update it there.
And when they push it out, then do they push product A? What a safer way would be possibly to push product A out to its own namespace?
That would be typically the way. If you're going to the same cluster, what I've seen is most people are doing different namespaces for each product in the same cluster.
Which obviously reduces the reuse of the microservices because they're isolating a shared microservice across namespaces.
Right. So this shared component would end up in two different namespaces. And the reason why they're doing it is they're trying to do isolation around security, the RBAC security in the cluster. So this is why I've seen there's, correct me if I'm wrong, but people want to keep all the traffic for product B in this basically one world, and all the traffic for product A in its own world. That's why they do the implementation that way at the namespace level. Even though you can have namespace and namespace communication, most people start out doing, they think of that as their runtime environment, that namespace.
Right.
Yeah, that matches what I've seen quite a lot as well. Early point on Kubernetes is generally for everything under one namespace called prod, or prod A and prod B, and hope for the best for a time until you realize you can do namespace and namespace networking.
So you could potentially have a reusable namespace where product A and product B could both reference that that.
Yeah, you can definitely set that up.
Okay.
So that's kind of the what I've kind of digested. Karam, I think I took care of everything I saw in your email. Did I miss anything?
I think so. Everything is taken care. There's the sharing part there that was like a bit confusing. How they like after definition, I don't think that's necessary. The sharing of the application also because the terminology is completely different. So the basic point is that we need a logical grouping of the services. So that's why we have this different names. So it can be application set, application, or it can be domain. So that's our product. So that's the only like the what you can say the whole conclusion that we can have.
Yeah, and one of the ideas Karam came up with, we were talking about the other day, was for component sets, using domains to represent a logical grouping of component versions. And I was looking at that, and I think in order to just stay consistent, I think we'll have to implement it more as a different object that can have its own domain as part of it, that a component set would belong to a domain. So I think even though it's a great idea, I think implementation wise, having component sets be its own object instead of redefining a domain to act as it is going to be easier from an implementation standpoint.
And if a component set then has it looks kind of like a component, and a component has, oh, we don't, would you define an environment to a component set or only to an application?
You deploy application or what we call products to an environment, and then whatever that product is made up of gets sent to that environment.
So could we, that's why I keep thinking of the release object that we already have. You think that we should be able to, a component set could be a product, but I guess it's really not. Because
Yeah,
a component set might get pushed out to its own namespace based on the application or now what you're calling the product, right? Or it might be pushed out to a separate namespace that is the common namespace. In that case, it should have its own environment.
yeah, it's one of those. The way I'm really looking at it as a component set really is a convenience way of grouping components together, and that.
Right.
So
Tightly
basically,
coupled components.
yeah, or it doesn't matter what, if they're tightly coupled or untightly. You want to make it a convenience way of saying, I want, for example, single sign-on. A single sign-on is made up of 6 components.
Because, right, and then you could always take if you wanted a group of of reusable components, that itself could be a product that has an environment.
Mm-hmm.
Okay, so we can handle both cases if we keep the component set where it is just a grouping and it doesn't have subdomains that are environments.
Right.
Okay, this stuff is confusing.
Yeah, and trying to draw this out, it gets even more confusing. So that's why when you start looking at different scenarios, the drawing the complexity relationships just doesn't fit in a single drawing. Every single use case that I came up with ended up being a different drawing. So
I think what we're going to have to do is add to the documentation. We might want to open up a ticket for this, is to explain how application, or if we call it a product, has subdomains that map to potential namespaces, because if that's how people are implementing it, so that they also can understand that the way we have configured it, you could potentially have a grouping of shared components that can be separated if they're having namespace communication.
Yeah, and that was one of the things, this component set, like I said, I didn't draw it here, but I can take this component set grouping here and I can move that into the middle where it's shared between product A and product B. You can have shared component sets.
Because by doing it the way the GitOps model is looking, you're losing one of the bigger benefits of microservices, which is the ability to reuse them and to be able to fix one shared microservice and everybody gets that that fix.
Mm-hmm.
So we're going down the road that we did with object-oriented programming, and we're going down that road really fast.
Right.
Everybody's renaming their own shared objects and making them their own.
Yeah. And one of the things, like I said, in both Argo and Spinnaker, they do not care about components at all. They are looking at the deployment manifests. They don't
They're looking
care.
at the product.
They're not even looking at the product. They're just looking at how do I copy something from point A to point B.
Right, but based
all
on the
that they're
way that
doing.
they're managing the Git repository based on a product environment, they're creating a deployment file that says deploy everything. They're creating a monolithic deployment.
Yes, that's what both of those tools are creating monolithic deployments through the process of using the Kubernetes manifest files.
Okay.
It's very much the distributed monolith pain.
Yeah.
Very, very much so.
They're still want to live in that world.
I was having this conversation about 2 hours ago, so it's very, very raw for me right now.
Well, we haven't adopted as a community, when I say we, this idea of reuse. We couldn't do it, and we've never been able to really embrace fully a service-oriented architecture. We're constantly pulling it back into our own little products and our own little worlds.
So comms over another time, but I would say part of the issue at the moment is the tooling around it is incredibly poor as a whole. And that's one of the areas where I think Ortelius can help a lot with that, but also just the tooling around managing these deployment relationships, having done quite a big evaluation recently, is incredibly weak and incredibly poor. I'll maybe look to write something up on that. And on the architecture front, Steve, I dropped you a message on Discord to the side of this thing. I do have permission from IGS to share a simplified architecture of this kind of component set problem. I did curse myself on the last meeting where I said, oh yeah, I've got a free week ahead. On the Monday, I got called up for jury duty and I only got off it yesterday. So I've been in that for 9 days. So,
ouch.
Yeah.
Do they do it? Do they do it via Zoom?
No, actually, they called us all into a cinema. They're paying to keep the cinemas open at the moment. All of the jurors go into a cinema socially distanced, and then there's a camera on each of your faces live streaming you to the court.
Oh, jeez, that's bizarre.
Wow. That is being creative.
Jeepers. Is that like microservices?
Yeah.
It's a brand new micro juror.
So that's kind of what I found. There has been other discussions we'll get into next time around it's another part that we've kind of run across as another problem set we need to address, which is associating additional trying to think of the word. For example, what's the Slack channel for this microservice that the development team uses? What's the where are the log files stored? What's the PagerDuty?
Yes, we need to add. We're thinking about maybe something that we can start a lot quicker is to add some metadata that support teams could easily use. So they have an issue. They know that there's a particular service that's having a problem. How do they know who owns it?
Yeah.
So one of the there's a really good example of that kind of thinking in the GitLab operational handbook, I think it is. They use Alert Manager with teams essentially self-registering in a custom service discovery thing, but there's some good documentation they've published around how they've approached that problem, which might be interesting for folk to read at least. and kind of the pain, some of the pain they had along the way as well.
And that was from GitLab?
Yeah, I'm sure I've got it somewhere buried in my millions of bookmarks, so I'll try and find it and share it in Discord. But that bookmark system is write-only right now, so it might take me a bit of time.
Oh, no worries. As long as I know which product team to search for.
Great. Yeah, so
Yes.
GitLab and monitoring, they've got some good stuff there. Sorry.
Yeah, I think that once we find out what those elements are, that those are kind of easier. I hate to call them easier, but those are issues that are easier to take on.
And one of the tricky parts for us is along those lines is, so let's take the log URL. Let's say we want for this component, this is where you can find the log files. That's easy to do for production. We know that it's running in GKE, and here's the stack driver URL with the filters already predefined for me to go look at the logs for this service. But now we go to a customer that has 17 QA environments and they want to look at log files for all 17 QA clusters. We get this problem of a one-to-many relationships and how we manage that. And that kind of comes across not only with like a log URL, but also with, the PagerDuty for QA may be different for PagerDuty for production. The Slack channel, those types of things are different for every environment, for every component.
So the environment level may have to have some additional attributes as well then.
Yeah, and like a config, like key value pairs or config maps, do you tie them to an environment or a component in the environment?
I think we're doing it both at this point, right? And one overrides the other.
Yeah. So it's just those are the concepts that we need to think about, how we can making the associations easy, but being able to display and make it useful from a user perspective is the hard part.
Well, we'll leave that up to you.
Thanks. I am the worst at designing UIs.
If
somebody designs it, I can write it.
You don't design the UI, just design the attributes that we need to add to each object.
Yeah, but that's down the pipeline. We'll talk about that next time. So that's kind of where we're at. Any questions on the application sets? Think about the concept of renaming application to product, what that means in your world, if that would make sense. If you were to implement Ortelius, if a product would make sense as that logical grouping of components and component sets, or if there's another terminology that would fit better. And we'll kind of touch base on that on our general meeting about that rename as part of that process. And take a look at in this doc, the relationships, just to get a feel for how things are related together, especially when it comes to the component sets.
Okay, everybody, that was a very educational call. I learned a lot.
Yeah, so did I. That was amazing.
Domains for us in Ortelius, that the image that you showed for component sets. So product A and product B will be our domains for us in Ortelius, or how it will be?
Yes, product A and product B would live in a domain.
And component set would be like a different object and also part of, what to say, it will be part of a domain.
It would be part of a domain as well. And the component set, the components that the component set is consuming or grouping together can come from multiple domains. And that was one of the things that when I was looking at the implementation, the flexibility that we get to span multiple domains of a component. So let's say you have single sign-on could be in the security domain. You may have, the login box in a front-end domain, and then you may have something else, the OAuth in another domain. That at the component set level, that would span all those subdomains that the components are coming from. But you at the component set level, you can call it, authentication would be the component set that we're going to work with, and that could sit at a certain domain hierarchy as well. Does that make sense?
Yeah, so basically, like we are changing the logic that we had recently, that a component can belong to only a particular single domain. So we are now expanding that it can be shared across multiple domains.
A component would
Basically.
a component would only live in one domain, and a component set can live in only in one domain. But a component set can consume components that are cross domains.
Yeah, so a domain doesn't restrict, you can't, well, like in our, in what we call our pro version, we allow you to restrict domain access, so you can't see it. But in the, in Ortelius, it's opened up so anybody can see any other domain. And the difference between what now Steve is calling potentially a product domain and a component domain is a product domain has subdomains that are life cycles, and the life cycles are environments, dev, test, and prod. But a component domain wouldn't have a dev, test, and prod because we wouldn't connect that to a specific environment. So component can be deployed to any environment, so therefore it doesn't have a life cycle associated to it. It's just an object that's reused by a product that then has a life cycle.
Yeah, originally back in the day, we used to have components and component versions live with an environment or a stage of the pipeline, and it was too restrictive. We weren't getting enough reuse out of it, so we pulled that away. So components live in a domain, and the product is the one that moves through the pipeline domains, and it's just a pointer back to where we're consuming it.
Got it.
But regardless of what product is consuming that, the component itself is deployed incrementally, and it has its own log. So Ortelius knows that if product A already deployed a particular component, it doesn't redeploy it because the component still has a history of where it's been deployed to, even though it itself doesn't have a connected environment.
A direct connection to the environment. It's an inferred one through the product.
Okay.
And that's where it gets tricky with when we look at our data model. A lot of it is a traversal, several hops to get to the information.
But it also means if we had somebody who's really good at writing SQL, that we do have component to component relationships. It's just going to require a few SQL statements to get the data from, like, take one component and look to see every application that uses it and every other component that it might touch.
And that would be one thing that when we look at the performance monitoring and the transaction side, building in a loop of transactions that would show a component to component relationship. But that would be a reactionary definition instead of a proactive definition.
Okay, sounds good. Tracy, I had pinged you on Discord regarding the CDCon, like I had some queries, and
Okay.
I thought like you didn't check that.
I did not. I did not look at Discord in the last few days. I'm bad at it.
Sure.
I will.
She'll get caught up.
I'll get caught. I will look at those today. You know, you always can email me directly too. I'm on top of email.
Okay.
All right, everybody. Thank you so much for coming today. And if anybody's interested, the CDF interoperability working group starting in a couple minutes. All right, thanks everybody.
That was awesome, man. Thanks. Cheers.
Cheers.